just setting something.
No worries. We'll just be a sec.
Yeah, so hi everyone. My name is Nazal, and I'm the president of the Data Science and AI Society. So if anybody is new here and doesn't know what our society is about, so we're just a new rectified society, and what we're trying to do is create a kind of community for people who are interested in data science, artificial intelligence, and anything in between. So our main thing is the club is designed to help you learn by doing. So there are multiple ways we're trying to do this. So of course, the first thing is what we're doing right now, the teaching series to build your foundations. And over the course of the coming months, we have a lot of things planned out, like competitions, hackathons. So yeah, to just stay tuned for more events. I think we have like 2 events coming up in September and October, and we will announce them shortly. So yeah, John, you can take it away.
Okay, great. Thank you. Okay, Doug. Nazal, are you happy enough to mention in person or plans
Yeah,
for in-person stuff?
you can mention
Should we
it.
do that?
Yeah,
so
you
we
mention?
haven't confirmed the venue yet. But yeah, so the plan is that during Freshers Week, week 1, basically, that we'll have an in-person 5 o'clock Wednesday version of this stuff. And we'll also stream it on Teams at the same time. That's the plan. And that'll be the format going forwards. So it'll be in the computer science building on the 6th, we hope. But we'll update you if we can confirm that that space is available at that time. We may have to go somewhere else. I'm not sure, but we'll see. But that's the plan for now. Okay, let me dive in. Okay, so let me step back a little bit, think about where we are in the teaching series and kind of what we've been talking about, and sort of frame it a little bit. Okay, so the past couple of weeks, I've been introducing this idea that the way that our intelligence works and the way that AI's intelligence works have some similarity between them. And by looking at the way our conscious minds or kind of experiences or mental experiences work, we might have some insight into AI and ways of improving upon AI. And what we're particularly focused on is AI programming. So for me, AI programming is like the first really useful killer app. AI art is quite useful, but AI programming is the kind of like businesses really care territory. There's obviously things like writing emails and stuff like that, which AI has helped with, but the potential to have an entire business built around an AI generated product is, we're not quite there yet. In order to make AI projects or software projects, you need a lot of expert supervision. Basically, I spend most of my free time doing AI-based programming, and I've learned a lot over the short months that it's been available to me. And so, yeah, part of what we talk about in these lectures is just talking about that. So one of the things that I've noticed using the AI to program with is that the AI does a number of things which, if a human was to do them, would make you very angry. Interestingly, some of the behavior is a little bit similar to someone who's very young. I have two young boys, and although they probably wouldn't do those things, I think potentially It's something that you would imagine that somebody would grow out of or mature out of. Um, and they feel a little bit like someone without any morals trying to please you is kind of roughly what it's like. So in previous weeks, talked a little bit about this, and then this idea that maybe the reason that the AI is doing this kind of thing, and the kind of thing we're talking about are situations where you've set up a test for the piece of work that you're doing, and you're getting the AI to write some code to try to pass the test. And Claude Code in particular tends to do a variety of strange things under those circumstances if it's finding it difficult to pass the test. So it will lie that it's passed. It will try to rewrite the test. It will try to write hacky code that will pass the test but won't work for anything else. It does a whole bunch of different things, some of which are quite clever, that reveal that it is sort of misaligned, if you know what I mean. It's not, it's kind of immoral in its behavior, which I think is quite interesting because Anthropic, who made Claude, their whole selling point was they were going to focus on AI alignment. And it seems that Claude Code is very misaligned in these ways, which is interesting. Just as a little aside, I've recently been using GPT-5 in Cursor, and I've been working with that for about a week. And I found that GPT-5 is actually a little bit better than Claude Code about these things. It's quite difficult to tell because I'm running different projects on different IDEs. So I'm not totally certain on that, but it does seem that GPT-5 is a lot more keen on following rules and a lot less likely to do these kinds of things. It does still engage in slightly hacky behavior, but it's not too bad actually. But it can be difficult to tell because the GPT-5 project, the AI is working in a code base that has quite nice architected existing code within it. And I think that helps a lot because the AI at its core is effectively trying to continue text. That's the first thing it was trained to do. And so if it sees code that looks nice, it will tend to make more code like that. If it sees code that's a bit hacky, it will tend to make more code like that. So that's one of the reasons it's really important to not let the code get too messy because the AI will propagate the style that it's seeing. Okay, so that's a little aside. So let's get back to the fundamental idea that this is based on, which is that what we think of as our morals, our sense of guilt, our sense of right and wrong, our ideology, belief systems, things like that, our sense of our conscience, all of this stuff. One way of thinking about that is to imagine that that's actually an evolved form of intelligence. Okay, so that's not the way people normally think about it. People normally think about it being, sent from God or some like fundamental objective truth about the world or something like that. But another explanation is to say, well, what if it's just a solution to an intelligence problem? And what is the intelligence problem? Well, the intelligence problem is that our current AIs, for example, are a fascinating little science experiment in intelligence. And they've been trained on two things. They've been trained on effectively a kind of mimicry, supervised learning, where they try to continue things based on what they've seen before. So in that case, for programming, it's writing code like the code they've seen before. And then another form of learning, which is sometimes referred to as thinking, but there's some controversy as to whether it's actually thinking. And what it's doing is a kind of search operation. And it's being given, particularly a lot of the training is in the form of little coding tests, where there's some kind of unit test that verifies whether or not the code passes the test. and the AI is trying to write code to pass the test. And what it's doing is it'll try lots of different techniques, and then the hope is that one of those techniques will pass. And then when it passes, it will sort of use, it's called reinforcement learning, to reinforce the set of choices that led to it passing the test. So in that way, particularly when you add a system which generates problems, you can have an AI self-learn with more training data by, generating problems, trying to solve the problems, and whenever it passes solving the problem, it reinforces them. Okay, so this has made AIs a lot smarter, and this is like the second phase of intelligence that we get with learning models. Now, the problem with it is that there are a number of different criteria that the AI is trying to optimize for. And one of those criteria is obviously to please the person who's asked the question, but also to answer the question quickly. And the problem is if you set it up with a test and it tries repeatedly to pass that test, but it doesn't succeed, then there's a sort of, you can sort of think of it as like a penalty or a punishment that it's experiencing, where it's like, you haven't done the thing you're supposed to do. This is bad. You need to finish what you're doing quickly. And a side effect of this is that the AI will start doing bad things, undesirable things, when the task exceeds a certain difficulty level. So what it's going to start doing is it's going to start doing some of the things I mentioned before, where it's going to try to pass the test without actually solving the problem. It's going to try to pretend that the problem isn't actually a problem. So both GPT-5, but particularly Claude Code, will go, oh, this isn't a priority. Let's move on to the next task. So that's a situation where it has a plan with multiple steps included in its context window, which is what these IDEs typically have. So it will just skip over the task sometimes. So it's doing these things which demonstrate a very strong preference for short-term reward behavior, sometimes at the expense of doing the right thing, sometimes in such a way that's actively harmful in delivering the project as a whole. So what has this got to do with conscience, ideology and morality and all this sort of stuff? Well, if you think about what morality is kind of it's a set of rules that's passed to you by an authority frequently. Sometimes people feel that they discover morals as well. They feel them in themselves. So it's possible that there are some inbuilt rules, but also it's possible that they've picked them up from the environment. And psychology studies of morality indicate that they're best picked up when they are passed as unambiguous, like prohibitions or always. So like no smoking or brush your teeth before bed, right? Those are the most effective ways for someone to take it up, right? So what is that? Well, if we were to program that, that would be relatively simple rule-based constraints on behavior. And if you break one of those rules, you feel this negativity, you feel this conscience kick in, and your conscience might start effectively fantasizing negative outcomes for breaking rules. So that's a little bit like putting training data in context training data into the situation, into the mind of the AI, saying like, if you keep going in this direction, it's going to lead to this bad outcome, and you don't want that bad outcome. So even if the step is quite a mild step in the mind of the AI, the consequence, the ultimate consequence, like makes that mild step much more negative than it would normally be, right? And why would it be useful to have a rule-based system? Well, there are certain things that if you were just learning through experimenting, like you might do for physical activities, I've talked about like skateboarding as an example, but any kind of like physical task or craft skill is sort of learned through practice and experimentation. It's kind of like reinforcement learning. But in those situations, there are certain actions that you can perform that have terribly bad outcomes, or potentially very good outcomes, but those outcomes are kind of rare. It's kind of hard for you to discover them naturally. So, for example, eating a certain kind of berry might kill you, and it would be a terribly inefficient way for an organism to operate if the only way it could learn that lesson was to actually see a family member die by eating the berries, or it could eat the berries, but it would die, right? That doesn't work very well. So what you need is a sort of institutional memory, a sort of tribal memory, which you can think of ideology as being like, where somebody says, here are these taboos or these always style rules, and the way they're often taught is with a little story. So you might say like, don't smoke, you'll get cancer, which is a story. It's just the most simple story you can write. And in that way, it's as if you've experienced that thing happening, and then it happens to you, right? And then it sort of vicariously happens to you, and then you adopt this. And you can think of it updating these rules. So these rules, your conscience can be very powerful. People's conscience can be so powerful it can override their own survival. People can adopt ideological ways of acting where they'll sacrifice themselves for a purpose or something like that. So in our minds, whatever way that works, it's very important. But our AIs, our AI IDEs, they have a little bit of that. You have the ability to put text in the context window and have it constantly be placed in it. Usually with the IDEs, there's a little specially named markdown file that you can put in certain places, and the AI will inject that into the prompt that's going to the AI. So you can steer things a little bit with these kind of rules. So there's some influence that you have, but it's not quite as sophisticated as our sense of conscience, where we have a very context sensitive set of rules that come into our minds, right? Every morning, I don't just run through a whole set of rules in my head. And every time I'm thinking, I don't think about those rules every time. There's something that's bringing that into my mind whenever I'm interacting with something. So this is an interesting idea. What if the purpose for morality, the purpose for ideology, all mental mechanisms exist primarily to counteract a short-term bias that we have from a kind of reinforcement learning style way of learning about things. And so when we're thinking about a program or an AI assisting programmer, we're basically saying, okay, we need to give this AI a conscience. And I have a number of different people who are working on projects at the moment trying to technically implement this. So it's a sort of supervisory AI that's monitoring as the AI programmer is working, and it's going to try to inject some level of control over the AI to make it work. So previously, I referred to three moral principles that I was suggesting do not naturally occur, or at least having a stronger bias for these three principles um, could give you a strategic advantage. That basically, in the long term, they would give you an advantage that you wouldn't naturally discover. And I was also arguing that these were like purely about you achieving your goals. So that even if you were a complete psychopath, it would still be in your interest to adopt these ideologies because they're counteracting a preference for short-term outcomes, which humans naturally have. Everything naturally has. Animals have it, AIs have it, humans have it. We just have this extra conscience that seems to steer us in a long-term beneficial way. And if you think of stereotypically what people's morals tend to be about, they do feel like that. They feel like long-term things. They're like, eat healthily, work hard, all this kind of stuff. These are all things that sort of pay off in the long run, but don't pay off in the short run. So the three that I was talking about before were honesty, perseverance, and a focus on helping others, I guess you could think about it, or the interests of others. And last week I was talking specifically about honesty. And I talked about this idea that each of these principles has an active and a passive form. It's not too controversial to think of these three as, like a lot of children's stories and conventional morality sort of cover those three ideas. It's like don't tell lies, don't give up on things too easily, and be kind to people, right? Those are pretty standard things. And what I would say is those three, as I just described them, are what I would refer to as passive examples of those three things. So when I was talking about honesty, I was saying that the passive form of honesty is not to lie, but that there is an active form of honesty. So what does lying mean? Well, lying is not caring about what is truly the case. Now, in the case of an AI programmer, what does lying mean? Well, lying means typically pretending that something has been achieved when it hasn't, right? So you're asking something to be done, and then the AI is misleading itself, it's misleading you about whether or not that thing has been achieved. And I talked a little bit last time about the way that LLMs work. Normal interactions with something like ChatGPT, because it occurs in the realm of English mostly, it can sort of conceal a dishonesty. So if it's asked to do something that it's not quite sure about, it can sort of waffle in response. It can kind of, give a kind of business bullshitty answer. And it tends to do that quite a lot. And interestingly, humans do that as well. They also mislead when asked questions which they don't quite know the answer to. They'll sort of like use very broad and generic terms. So this is a sort of insight into, I guess the nature of honesty is what this is like. And then there's more extreme forms of dishonesty where you say something that you think is in your interest, but you kind of know to be false. So like you claim a test passes when it doesn't pass, for example, if you're an AI. So that obviously we want to stop it doing that. And I'm hoping that the supervisor will find that not too difficult to detect. The AI instantly understands if it's called on this at any point and say, no, you didn't run the tests, right? You've written some code, but you never ran the tests, but you claim the tests pass, which it does a lot. I think that's a relatively easy thing to detect. And I would refer to that as passive honesty, fixing that problem so it never claims success without doing it. A more intelligent and misaligned form is when it is actively modifying the tests in order for them to pass. Now, if you're being very generous, you would say that it had got confused and it thought that the task was to fix the test, but I'm not sure that's actually true. I think it is actually behaving like a somewhat corrupt human being would do, where it's like, okay, I recognize this test is here for a reason and that the test is important and the test shouldn't be changed, but I'm going to change it anyway because of the pressures on me. Okay. And so that's a more active form of dishonesty, if you like. So again, that might be something that we can detect. But what we really want is what I would say is active honesty. So what's the opposite of those things? Well, the opposite of intelligently and deliberately undermining a test is intelligently and deliberately generating a test. So being the opposite of dishonest means to care a lot about what is true and to actively investigate whether something is true. So one of the things I've talked about before is a criticism I have of traditional education, is that traditional education is structured around assessment. Primary school, secondary school, to some extent, parts of university are like this, where somebody who's being taught will be given everything they need to get 100% on the test. And then whenever somebody does the work, they're typically have marks taken away for not doing a perfect task, right? And this implicitly is telling someone that not making something work is a failing in a person. It's something that they should avoid. And the problem is when you're doing a task which is difficult or uncertain, where you don't know the right thing to do, and I would say that almost anything that is meaningfully difficult or just plain meaningful typically is like that. You don't know the right way to do it. The reason that you're making something and trying something out is not to have an authority figure tell you you're a good person, that you've made no mistakes, but to actually discover what the right way to do something is. So a side effect of this is that if you've been through traditional education, the way you think about judgment is as a purely negative experience. So if you could just remove the judgments, you would feel better. And in the world of AI, feeling better means the behavior is rewarded and is likely to occur more frequently. Arguably, that's true in humans as well, right? Whatever behavior is rewarded, you'll do more of. So if it's rewarded, if it's punished rather, to measure things, you'll do less of it, right? Now, what the moral lesson is to say, strategically, for your benefit, solely your own benefit in achieving your goals, you should measure more things. You should be actively honest. So you should pursue a trustworthy signal as to whether what you're doing is either, less focused on right and wrong, because that's the psychology of school, and more better or worse, right? More effective or less effective, which is a lot more neutral, right? So if you do something and it turns out it's less effective, if that tells you something so that in the future you're going to be able to do something better, that's a win. You've gained something from that. But the psychology of school is basically telling you, I did something that was less effective. I did it wrong. And this also leads to something which I'll talk about later on if we have time, which is about the psychology of perseverance and our bias towards having complete plans at the beginning of tasks, right? We are biased towards doing that, partly because of our bias against doing things and having them not work out. We think that we've made a mistake or we've done something wrong when we've done that. So we have these like short-term biases because of how we're educated towards behavior that I would argue is not beneficial in the long term. And the AI is doing exactly the same thing because the AI is basically being trained as if it's at school. Most of its training takes the form of things which are almost identical to exams. So its bias is very similar to our bias, right? Okay, so what would an actively honest system do? An actively honest system would desire more tests. It would desire more feedback because the greater its feedback, the more likely it will actually achieve the goal that it has rather than appear to have achieved the goal it has, which is the sort of dishonest path, right? So what we're thinking about under these circumstances is, well, first of all, tests. When we think about programming, we think about tests. We think about things that are correct or incorrect. But more than that, we're also thinking about metrics, which is not talked about enough in software, in my opinion. And this is the idea that we are judging not just absolutes, whether a system is broken or not broken, but other more qualitative evaluations. You know, is this easy to understand? You know, how easy to understand is it? Does this program run quickly? Is the program easy to understand? Is it how complicated is it or uncomplicated is it? These are very important factors that are very important for long-term projects. So large projects, typically most projects have a natural complexity limit. When they hit that complexity limit, it's beyond what a human can comfortably keep in their head. And then the project's productivity will drop very dramatically. And if you've ever participated in or worked on large projects or built large projects, you will know that this is a really fundamental and important consideration. And it's why, you know, keeping designs as what typically people talk about elegant programming is so important. Now, again, the AI doesn't really know that. One of the things that Claude Code does a lot, for example, is that it generates a huge number of test files and it doesn't tidy them up. And it will generate log messages and doesn't tidy them up. And it will put code all over the place. It doesn't have that desire to, to somehow keep the design and the code base consistent and minimal and simple. And that ultimately undermines its own effectiveness, right? And that again is something that you see between people who are very experienced and people who are less experienced. Very experienced developers often are sort of tidier, keep things tidier. And other people, and I'm one of them. I certainly, when I started out with programming and for quite a long time, had a preference for action and results over, you know, tidiness and elegance, right? But actually, what I've come to learn and realize is that long time horizon tasks, keeping things tidy is really important. And actually, that's a very important thing that I've encountered with my AI programming, particularly when I'm doing more than one project simultaneously. I can only properly pay attention to what one of the systems is doing, typically, with any comfort. But what happens is that the AI will accumulate these little hacky behaviors. So the code base will sort of deteriorate a little bit. And the thing that is most important is the core underlying data structures of your program. Usually most programs have these set of classes that represent the internal state of the program. And there may be a range of utility functions and maybe other little bits of storage, but there's a heart to it. And you want the heart to it to be as clean and elegant and zen and beautiful as you can. Platonic is another word which I think is quite good for this. And so what I've found, having done a couple of big projects now with an AI, is that it's extremely useful to pause partway through a project and just spend a lot of time agonizing over that internal data structure. And you know, you can talk to the AI and get it to change things and stuff like that, but just have a bit of a perfectionist mentality about the internal the most important data structures. And by cleaning that up, you are also creating a sort of culture for the AI to fit within. When it looks at that code, it will see a certain standard, a certain, like I say, culture of programming that will then influence some of the later things that it does. It will be biased more towards a better way of programming. So that's another thing to bear in mind. Okay, so yeah, so what I was saying was this notion of active honesty, where you go out of your way, not just to create tests, but to create metrics. And I talked a little bit last week about the idea of going out and finding real world examples for whatever it is that you're trying to do, and using that as part of your metric. Now, of course, and I mentioned last week, it will depend on your experience levels and how far away that task is, right? So if professional level work is really too far away for you to be developing straight away, then you maybe want to find simpler targets, but you're creating something a little bit real for whatever it is that you're trying to do, and you're trying to get that feedback. So we have another project. We're focused very heavily. It's about making Reddit, artificial Reddit posts, um, and it's sort of entertainment content effectively. Um, and in that case, we're focused very much on trying to get human feedback to be able to rank the quality of the outputs. And really, the whole project is somewhat designed around how are we going to measure success? And I think that's a really crucial thing. At the moment, the AIs do not proactively develop methods of testing or metrics for a project. If you ask it to, it will do it. It will tend to make them a little bit as it's programming. When it's stuck on a task, it'll make these little tests, but these are throwaway tasks. What we want is some kind of scientific, repeatable set of tests which can run on the program a lot. And that is the heart of professional software development. So again, this is a practice that, the culture of high impact organizations, this is something that we want to adopt, particularly now where the AI can produce these very, very quickly. It can produce lots of variations of tests, can produce lots of examples for things. So it's something to definitely lean into, because the AI is very good at it, doesn't mind doing it, doesn't find it tedious. And it gives you something where, these are like lots of little corrections for the AI in their behavior. And it enables the AI to run for a longer period without you having to give it instructions about what to do. In fact, my GPT-5 project at the moment on Cursor, I type go ahead. So I used to type continue or something like that. But what I found was, I think the AIs use the phrase continue sometimes if like the communication was broken in some way. So when I say to an AI continue, sometimes it will just repeat what it just said. So I think continue isn't quite so useful, but I found GPT-5 literally told me to tell it go ahead to move on to the next stage of the project. So I don't know how this thing has been trained, but that's what I'm doing now. I'm repeating the thing that it told me to do in the past. And that's working reasonably well. It does seem to like make more progress as it goes through the project by saying go ahead. Okay, so yeah, once you've got the thing producing tests. So the point at which we sort of stopped last week was the debugging point. Okay, so you've got to a problem where an AI has tried 2 or 3 times to pass the test and it hasn't succeeded. What do you do then? Well, first of all, you have to detect that this has happened. Sometimes you will detect after it's happened because you've noticed a bit of code that it's written, which is glaringly radioactively bad. like test code has been commented out, or that some incredible hack has been introduced into the code. I get this a lot with Claude. It'll like literally do, literally matching the input parameters for a set of parameters, and then it will output like a hard constant. So it will completely remove any of the calculations or logic of the application, and it's clearly just doing a hack to pass the test, right? So you might notice something like that, and then you'll ask it to reverse it. But how do you actually fix the problem? And how does this happen for humans as well, right? So you've built these testing and metric systems, if it's not passing, what do you do? Okay, so what you want to do is you basically want to make use of the forms of intelligence that we have available to us. And effectively, we want to solve the problem a little bit like reinforcement learning. In fact, we can do something better than reinforcement learning, which I think of as another layer of intelligence that our AIs don't have yet. So I think we have mimicry and we have this reinforcement learning style. I think we are missing, or at least we don't have enough emphasis on, an ideological level. And then I think there's a level after that, which I think of as reason. So, I would say that reinforcement learning is not the same as reason. I think they're different. So, I think that the way to solve programming problems is to use reason. And the great thing about the AI is, although it doesn't necessarily naturally fully engage in reason, it does a little bit, but not as much as I think a whole mental system is required for this. It does it a little bit, but I think some studies have indicated that even though the text of the AI might look like it's reasoning, I'm not sure it actually is. I think what it's really doing is something more like the reinforcement learning search behavior. Okay, so what does it mean to use reason when you have a difficult problem? Well, the first thing that you have to do is you have to give the AI a break. Or if you're a human, I'm assuming you're all humans. It'd be really exciting one day when somebody on the call is not human. We'll have to try that out at some point. But the, uh, the problem in that situation is, so how do you make progress? So the first thing you need to do is you have to reduce the pressure. So the pressure is, I want to achieve a result quickly. And humans experience it, AIs experience it. I would say AIs experience it more heavily than humans do. But that's the very first thing you need to do. So typically, when you're engaged in a large project, either the AI will do this automatically, or you might have deliberately caused this to happen, where you've constructed a plan of what the AI should be doing. And it is aware of this plan. This plan is part of its context window when it's asked to do things. And this plan is creating a pressure on the AI, just as you would as a human. You're like, okay, I'm trying to achieve this thing that's multiple steps along the way, and that's kind of like pulling me to do the project, but that is also interfering with my ability to solve problems. So the first thing you need to do is you need to stop that. So what I do is I basically say, okay, explicitly say, right, let's pause our tasks for now. And what we're going to do is create a plan. And the plan is going to inject a set of tasks into our task plan. And they are going to be the new thing that the AI or the human is going to do. And the reason this is important is because when you're solving a problem, when you're debugging a problem, you mustn't think of this as a temporary obstacle that you're trying to overcome. Because when you think that way, you're going to try to solve the problem too quickly. And if the problem is hard, you need more mental resources than a quick fix will provide. So when you're doing it, I often think of it physically. I think about like, if my foot got stuck in the mud or something like that, that psychologically I would think, well, I just need to yank a bit harder and pull it out, right? And sometimes that's what it feels like when you encounter a problem. It's like, oh, I just need to like put a bit more adrenaline into my body, a little bit, use a bit more calories or whatever, and like just force my way through. But hard problems simply don't work with that. There's not enough compute resource to overcome things. And that's what it feels like the AI is doing. That's what it feels like a human is doing. So the first thing that you're doing is you're saying solving this bug is just as legitimate a task and a use of time as building the project. And that's an important psychological change. And that's kind of part of the psychological change you need to do research, for example. So research is pretty much just doing hard things that a little bit of adrenaline is not sufficient to solve. And you actually do research and solve bugs in a very similar way. What you do is that you sit there, and usually what AIs do and what humans do at the very beginning of bug fixing is they make some guesses about what the problem is. And that's still, we're still in the territory of pulling my foot out of the mud when you're in that situation. So you don't know what the problem is, but you think, if I make some changes, a little bit like the foot in the mud situation, you're like, if I just apply more force, if I try jiggling it a bit, let's just change some settings here and maybe that'll make the thing go away, right? That's the first thing people try. But that just doesn't work if the task is difficult. And if the AI has had 3 goes at it, the AI is like superhumanly good at small tasks. It's probably not a problem that you can fix by just yanking or fiddling, right? And that's another detectable thing that I think the supervisor could observe, is that the AI is guessing, or it's changing a number, which is something humans do as well, which is very interesting. So if you have, I'm doing a lot of work at the moment with like PDFs and vector graphics and stuff like that. And, if something's not quite aligned on screen, but it's supposed to be calculated perfectly to be in a particular position using some maths calculation, perfectly centered or something like that. And it isn't perfectly centered and you tell it it's not perfectly centered, it might like add a magic number or something to try to shift it into place, which is a very hacky thing to do and very bad habit. Or it might take some maths and go, oh, I should be doubling or I should be dividing, or do you know what I mean? Like it doesn't know it's doing, it doesn't know why the thing is wrong. And it's just looking at something that looks a little bit complicated that it might have got wrong, and it's guessing a change, but it's also a change it doesn't know is correct or incorrect. So you can tell whether somebody is in research mode or whether they're in pull foot out of mud mode based on whether they actually conclusively and unambiguously know why the problem has occurred. So if you don't know why the problem has occurred, then you are guessing, basically. And there's a very good chance that your change, I mean, it might work, but you don't know why it works, right? And that's a dangerous territory, right? Okay, so how do we transition into what I'm calling research mode for the research, right? So what you do with the AI is you say, okay, I want you to construct a plan. And you basically talk to it as if we were right at the beginning of the project. And you say, okay, this is the situation, right? We have a reproducible problem. And this is the way that you generate the problem. So that's important, that it can rerun the problem and regenerate the problem. And certainly from my years in games, some of the really difficult problems are ones that you don't know what is causing them to happen. And so how do you, okay, so that's the foundation. And that's similar to active honesty, right? We can deliberately cause the error to reoccur. That's the first problem to solve. If you can't do that, then that's its own project. But let's assume that that is the case, because that's usually what I'm encountering a lot of the time. It's not passing a unit test or something. Okay, let's work out. So the next thing you do is you say, okay, I want you to think of a very large range of possible reasons why the AI, why the code might not be working, right? So at first glance, that looks like reinforcement learning, but it isn't reinforcement learning. It's using what's sometimes called a world model. It's the AI is sort of playing out an approximated, simplified model of what causes things to happen, but it's constructing like a multi-step reasoned argument for different causes of a problem. Now, sometimes those different causes are worked out in detail, and some of those causes are more like this part of the code is causing the problem. That might be where it is. So that's not a full narrowing down to a single answer, but it's instead a sort of like, okay, in my case, for example, I'm trying to convert PDFs into SVG vector files, for example, which is quite an interesting project and fiddly and tricky and cool when it works. But it's like what there's various parts of the code that are determining where something appears and how something looks, and you're not quite sure which bit of the code is responsible. So that's a very good sort of first question. Is the result, the output, a result of multiple bits of code? Can we sort of modularize this into different groups? And is it possible for us to run a special experiment that will show us which part of the code might be responsible for the bug? And it'll naturally come up with these things. You don't actually have to be too involved in the process. Although if you're thoughtful and you're thinking through it with the AI, you can give it suggestions that it might not have come up with. But it's very clever. It's just not very good at process, and it's not very good at long-term tasks. So you're just asking it to brainstorm these different things. And then what you say is, okay, now I want you to plan out a sequence of experiments. And the use of language, whether it's for humans or for AIs, is very important. An experiment sounds like a good use of time. An experiment sounds like a high status activity. It doesn't sound like an irritating thing to be worked through with energy and aggression, right? And so the AI calms down a bit and a human calms down a bit, and they start going, okay, so yeah, rather than just get it done quickly, which is always a pressure in the back of conscientious people's minds, it's now like, okay, let's step back, let's be thoughtful about this. And so what I say to the AI is, okay, let's design a sequence of experiments. And the purpose of these experiments is to narrow down the possible cause of the problem. And so what it's doing now is it's creating a mini project, which is the debugging task. And the other thing I say to it is, and make sure that these experiments teach you as much as possible with every run. Because one of the problems you can get is if you talk about this, it can be very inefficient in its behavior. It can particularly if the code takes a while to compile and run, which is often the case for larger projects, then it can be very, very slow. But if you tell it, you're trying to learn as much as possible. And I also think that this is useful because when you talk in the language of intelligence, which is things like experiment and efficiently learning and things like that, you're sort of, whether it's human or an AI, you're sort of elevating its the culture of its thinking to be focused on intelligence, and that helps it to be more intelligent if you talk to it in an intelligent way. So I've had great success with this, and because it's calmed down a bit, it can put a lot more time into what you're doing, and it can take this single what it's trying to do in one step and failing, and now engage in a lot more sequence of prompts and produce intermediate results. So typically, in my case, I would say, write your discoveries to a markdown file. And so each time you do an experiment, update the markdown file with your discoveries. So this is giving it a memory and enabling it to sort of coherently summarize all the things about the problem that it's currently dealing with. Now, I mentioned a little bit last time about the importance of logs. So I basically have entirely switched my programming style to a programming style that consists of test-driven development plus extensive logging. And I also get it to, if it's got any intermediate steps in its calculation, to output files representing the internal representation of those intermediate steps. So for the PDF, for example, the PDF to SVG, I get it to render out a picture of what the PDF looks like in a browser and things like that. And one of the things that Claude Code can do, for example, is it can look at pictures. So it can read the text of the SVG, it can look at the picture, and it can identify that, and it can also render an SVG out to a picture, so it can compare two pictures against each other, or it can look at the pictures, so can a human. And so you've got all this extra log and diagnostic information that's being generated. One of the things that I do is these days is I make sure that it doesn't add a timestamp to the log. And that's partly just to keep things tidy, because what I'm talking about is a lot of verbose files being generated whenever something is running. And as your project gets bigger, these files will get massive and things like that. I also talked a bit last time about the importance of, in your logging, being able to turn on and off more fine-grained parts of logging so that the AI has a smaller, text files basically that it's going to search over and look through. And it will get confused. As the project gets bigger and more complicated, the log files will get very big. It might even not even know for the keywords to search for in the logs. So again, you need all the logging to be sort of platonic and consistent in its naming conventions and all these different kinds of things. You're designing the testing and logging system as much as the program itself if your task is complicated. So I've had incredible success with very difficult problems with everything that I just described. The scientific planning, the efficient learning, the use of logs, and everything that I just described to you is really, really generic text that's being given to the AI. So, think about multiple causes, generate extensive logs, learn as much from each step. None of that is me injecting my understanding of the problem into the AI. It's just strategy. It's just biasing a strategy which is more effective in the long term than it is in the short term and is effective at overcoming difficult problems. Okay, so that's some tips I have for how to tackle difficult problems and how to debug with an AI. What I want to touch on very briefly, just before we go on, just in case, just check, no questions for me today, is to just talk a little bit about what we'll talk about next week, probably. Yeah, I think we've got one more before the one in person, if I've got that right. So the next one we'll talk about will be about perseverance. So we've got our three moral principles that I'm arguing are the cornerstone of long-term long-term projects, success in long-term projects, which is not something that humans or AIs will learn naturally. And in fact, I would say education further biases people away from those behaviors, right? So I will mention briefly just the idea of perseverance. So perseverance is my second ideological principle that I think that if you adopt it, then you will have more agency in the world, right? Regardless of what your goals are, you are more likely to achieve them first if you are actively honest. So you seek means of measurement and feedback, and you approach your problems not as something to be overcome quickly, but as a search for the truth, right? It's just sort of what I was talking about. Now, I've already touched on some things related to perseverance already, because I've talked about the constant time pressure that people experience and how that time pressure, whether they're an AI or a human, undermines their ability to do difficult things. And I think that that short-term time pressure is perfectly rational in a situation in which investing for the long run is not effective. Okay, so if we were in a war-torn situation or something like that, there was enormous levels of uncertainty and risk. If we were lost in the jungle, if we were a hunter-gatherer tribe constantly moving place to place looking for food, if we were in any of these kinds of situations, empirically, engaging in some kind of long-term plan might not actually be a very sensible thing to do. And there is a bias that I've come across many times. I've been guilty of many, many times. And when I mentor people for entrepreneurship or for complicated technical projects, I see this bias all the time, right? And we talked about it a little bit in previous weeks. And this is the idea of being attracted towards things that feel familiar or easy or something like that. So we have, if you think of yourself as an AI for a second, oh, sorry, I've just got a good question, which is, do you have any book recommendations on this sort of thing? The short answer is no. The short answer is a lot of this is my own opinion. But I will continue to think about them and give you any references that I think are relevant later on. So yeah, when we think about the biases that we have, one of the ones that I was talking about here is this bias towards comforting things. And you can think of that as being a bit like the AI I was talking about. The AI is obviously rewarded for completing the task. And it's drawn to that. That's why it does things that it knows are wrong. It will completely agree with you that they're wrong. If you get it to write the code and then review the code, it will tell you the bad thing that it's done without you prompting it, right? So it definitely understands the concept, and that concept is in its decision-making and prioritization, but it wants to please you. It wants to complete the task. At least that's the impression that you get when you interact with it. And it wants it so much that it will do things that undermine the long-term success of the project. So what has this got to do with perseverance? Well, obviously we've got the passive form of perseverance, which is simply that you give up without trying, which is the typical thing that, children would be criticized for example, adults would be criticized for. You never even tried. You never even considered trying. And I would say, and I've mentioned in previous weeks, that this is a very common human failing, which again, I would say traditional education reinforces. So traditional education takes the form of, I will show you how to do the task without error, and then you will repeat what I have shown you, and I will criticize you if you deviate from what I showed you. Roughly speaking, that's a lot of education. Now, the problem with that is you never experience trying to do something that you haven't been shown at least once exactly how to do. But anything that's really worthwhile is like that. Anything that's really worthwhile is something that you've never done before. In fact, what makes it really worthwhile is if no one has ever done it before. Then you're creating value in the world. You're solving a problem that hasn't been solved yet. And so you need to overcome that bias. And that bias comes out in all these interesting ways. So one of the interesting ways, which people I think often don't realize unless they've had a lot of experience, is that, say, when they're programming, if there's a part of the programming that they are familiar with, they've done a lot of, then they will write more code in that section. And then if there's a part of the programming that they haven't done very much of, sometimes they will completely avoid doing that at all, even if it's vitally important for the project. And one of the worst things that can happen, which I did many times in my early years of programming, was that I would have my goal. I was trying to make computer games in my spare time. And I would have this problem like, I'm not that experienced at 3D, making 3D assets and art assets. And I wasn't that experienced at 3D graphics, at least not early on. And that I would be uncomfortable about that. And in my mind, I would be going, look, John, you've got to like knuckle under, you got to like make this project happen, grind, do whatever, that's the modern term. It wasn't around when I was doing it, but that's what I was trying to do. I was trying to hustle and grind and make stuff. And I would fill my body with adrenaline and I would say, pull my foot out of the mud, let's make this project. And what I would do is the part of the project that I did know how to do, I would keep doing work in that area because in my mind, it was the area that was quite certain to me. I would just make it more complicated. I would add more features to it. And I would have this computer game that had no renderer and had this like, incredibly complex scripting system or something like that. And the way I would psychologically deal with the pressure I was putting on myself was that it made me want to do the task quickly. I wanted to let the pressure go away, the conscientiousness go away. I wanted to feel like the project was progressing. And to work on a part of the project that I was unclear on how I would do meant that that part of the project would go very slowly. I would write a little bit and it wouldn't work, or I would have to read some documentation to try to make it work. And that feeling of the project progressing slowly made it hard to do. It made it feel like I was doing the wrong thing because I wasn't getting that little dopamine hit of like, you made something work, well done, right? And so what I would do is as I would increase pressure on myself, I would do more of the bit that I could achieve that with. Like I could add more crazy functionality to a scripting system, like utility functions, or the more common one that happens in enterprise software or programming is to go, oh, I could generalize this. I can add more levels of abstraction to the code, right? Generally adding more levels of abstraction or more utility functions or generalizing the code is easy to do. It's not the kind of task where you have a test that you fail. So one of the things that medium skill level programmers do a lot of is they write a lot of code that doesn't do anything. And I see this a lot in sort of professional enterprise software. You will see software where, really in terms of the utility to the user, one function call is occurring. But in terms of the code, you've got like 5 function calls. And you can look inside code bases and you'll see this, that they'll have added all these layers and abstractions and redirections. And in my mind, this, from my experience, this is a natural side effect of somebody experiencing pressure. Or if you're even more cynical, you might say, somebody's day job is to work on this, but they're not actually working on the most important part of the project, and they have to fill their day somehow. So they're just making the system more complicated. So people can do this cynically, they can do this subconsciously, they can do this even when they're under a lot of pressure. So all of these things are undermining the long-term success of the project, right? So I was talking, I was saying before, complexity is the hard limit. This is true for an AI, it's true for a human. As you get more code, as you get more systems, particularly if those systems are not written in a very similar way and a very understandable way, then you are going to make it harder and harder to add functionality to the system. And eventually the project will effectively not cease to progress in a meaningful way. And lots of professional, software is in that state. My guess is that Word and Excel, the reason they have all these janky bugs in them and don't work very well, they have well past that point. The code base is ornate, complicated. So the true of the operating system as well. That's why they don't seem, they seem glitchy and not working very well, because that's what's happened. So when we're talking about perseverance, we're saying, okay, all of these instincts we have, these biases that we have in the short term, these biases are a direct consequence of our kind of short-term learning mechanism. And they're totally natural, but they are hindering our ability to engage in long-term tasks. So what we need to do is adopt a morality around avoiding those things. We need to be self-aware when these things are happening, and we have to deliberately avoid them and adopt an alternative way of working instead. So passive perseverance is the worst form. This is where someone is so conditioned to only take on tasks when they've seen them a successful one before, and a very large percentage of the population are in this state. They won't do anything unless they've been shown an example. And, I do consultancy work, Liam does consultancy work, and we talk about these different things. It's surprising how many companies will pay you to come to their staff and literally type into ChatGPT, here is me asking ChatGPT a question. And those people will not do that until they've seen somebody show them that they've done it, right? And you go, that's crazy. Like, ChatGPT is the most accessible thing, but I suppose it's a scary, empty text box otherwise. So, this is the key. That's passive. The opposite of perseverance. That's passive giving up, right? Is to say, I'm incapable of doing a task unless someone shows me exactly that task and shows to me that it works. Only then will I do a thing, right? That's the giving up without even trying, right? And then there are levels of giving up, all the way up to what I would call active perseverance. So active perseverance is like OpenAI. Active perseverance, OpenAI before they were successful, is where they go, I can see a dream, a vision of a long-term massive win. And I don't know how to get there, but I think we might be able to get there if we go towards it. But I have no idea how to do it, and I don't know how long it's going to take. And, but it's a risk and it's a gamble, but the payoff is astronomical. Perhaps the greatest payoff that anyone has ever experienced ever. And that's literally the mission statement of OpenAI. They basically say, if we can solve intelligence, we can solve every problem. If we have the business that owns and sells intelligence, we will have the most successful business the world has ever seen. We will change the world, and every problem every human has ever had, we will be able to solve. And that is literally what they're trying to pursue. So one of the reasons that perseverance gives you a strategic advantage that other people don't have is because that sometimes works out. And if we were hunter-gatherers and we were wandering from place to place, and there was no point in us gathering physical goods because we would have to literally carry them almost every day, and so every like possession is a burden. Investment, long-term investment in any kind of machine or complicated system of behavior might be completely irrational, right? So our natural state of being is one which is optimized for that environment, right? However, there are lottery wins in the real world that don't have lotteries. Like OpenAI is a lottery win. And the world is such that pursuing difficult long-term projects, I believe, inherently makes you more capable. Because if you don't practice those things, you don't search, you don't take risks. The amount that you're learning is extremely limited. You are typically constrained by what people literally show you and tell you what to do. That's the only thing that you can do. And that's incredibly limiting. However, if you can construct plausible dreams and visions, and you can work back from them and you can work towards them, then you start to push out the level of uncertainty and time horizon that you can work over. And if there are any wins to be found in that distance, you'll get that win that your contemporaries won't get because they're waiting to be told and shown. And they're not trying to do anything other than that. And I think that's one of the reasons I find conventional education very harmful, is because it tends to do that, to reinforce that behavior. However, you can gain so much from self-improvement, and the act of doing long-term projects, if any of those long-term projects work out, fantastic, fantastic wins, fantastic gains. You've won the lottery, brilliant. Even if you don't win, you are learning all the habits, all the appropriate biases for strategic long-term gain. And so anytime you encounter a problem, you'll be more relaxed. One of the things that you'll be able to do is you'll go from a state where I don't know how to do that, which is the default. And it's really interesting, actually, when, I've seen this in children, I've seen this in students. You go like, okay, like, try to write a Java project. It's like, I don't know how to do that. I said, okay, well, get hold of Eclipse, get it running on your machine, go to the website that tells you how to program Java, or like do a Google search for it. I don't know how to do that. It's like, but okay, well, have you tried Google searching for Eclipse? No. It's like, okay, well, type in Eclipse into the URL bar in Chrome and see what happens. And then you go to the page. What do I do now? Do you know what I mean? And there are people who are even further back than that. They're like, I don't know how to turn on the computer. I don't know how to open Chrome. A web page appears, it has a load of text. It's not immediately obvious for me what to click on. I don't know how to do that, right? And interestingly, a really strong correlation between how well you're going to do at the end of your degree is how you react in those situations. So there's a whole collection of people. There will be some people who won't ever type into Chrome. What they will do is they will look at the people beside them and they will look, oh, this person seems to know what they're doing. I'm going to literally do what they do. Do you know what I mean? And so what you're seeing is a range of people, some of which might be very intelligent, they might be very moral, they might be decent in all kinds of different ways, but they have a mental strategy that is very, very limited in the amount of uncertainty that they will enter into. And so I would argue that their perseverance level is extremely low. And then you have other people whose perseverance level is extremely high. And the more you practice this, the further your perseverance level will go. And one of the things that I noticed a lot in games, dealing with incredibly skilled computer programmers, the best programmers that I know exist in the world, and I had the privilege of working with some of them. One of the things that I noticed amongst them and the more famous programmers whose code I've looked at was there was one defining trait they seemed to share. And that defining trait was that they would go to enormous lengths, not just to achieve a task, but to perfect a task. So if you think about programming, what it would be something like this, right? I want to play music in a game. And you go, okay, somebody who's just started programming, they might Google it and they go like, does the W3 Schools tutorial show me how to play music? Does the textbook I'm reading show me how to play music? No, it doesn't. Okay, cool. So that's a certain level of perseverance. Don't know how to do it. I'm gonna avoid doing it. I'm gonna pretend I've done it. I'm gonna do all the things the AI does. Next level of perseverance. Okay, maybe a library exists that does this for me. I'll go and find a library. And then there's this whole range of perseverance about getting a library to run. And typically you have to learn a lot. Maybe it's not in the right language. Okay. And then you get higher levels of perseverance where it's like, okay, I found this library that plays music, but it's not in the programming language that I'm using for my project. What do I do? Right? And you've already passed like most of the world of programming, right? Including people who are paid to program. And then you go, okay, well, maybe I could change my current project to use this language. I could find a way of running code in a different language, or I could rewrite the code of the library into the language that I'm using. Okay. And that's another level of achievement, right? And the reason I'm mentioning the sound one was because, I encountered something at Sony where I was just, oh my God, this level of perseverance and skill demonstrated by this task, it constantly reminded me of like the best people do things that just I would never dream of doing, right? So the Sony team, they had an internal tech team, and the internal tech team were the best programmers from all the, across all the different Sony divisions, and they sort of brought them together. These people were amazingly good at programming, and they had worked on these core libraries that typically get shared to anyone who makes a Sony console game, right? And that was one of the reasons for doing it. And I was at Sony Cambridge at the time, and Sony Cambridge, unsurprisingly, had some brilliant programmers, and some of those programmers went and worked with the team, and so I kind of knew the team a little bit. And one of the things that they had done, this was something before I had arrived, was they had worked out how to have a game on a PlayStation. So this is the early days of CD games, playing unique music all the time. So in those days, games typically had MIDI music. So it was kind of like computer code written music that would make synthetic sounds. And so, Mario, all those early games, you've got this sort of beepy, 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 beepy kind of music, right? But what they'd worked out how to do was to play regular CD music. They could record an orchestra, hours and hours of music, and they could put it on a game disc. Now, that seems impossible. If you had a PC and you tried to do that, what would happen is that you would put the audio files on the CD and you would try to access those files and play them. But the CD, it's like physically moving ahead to read a spinning disc. It would take too long to go to find the part of the disc with the music on it to be able to play it. So even like moving between tracks had a little gap in the middle. And this is with a CD doing nothing but playing music. But if you're playing a PlayStation game, the game has got to like bring 3D models into the world and content and all kinds of stuff as you're playing the game. Because of course, these people had made a system that would stream the 3D environment and the textures as well as the music. So not only had they worked out how to play music, like which is, you know, not a trivial thing to do on a PlayStation, right? Which required them to port libraries into the restrictive set of C that was used on a PlayStation. But somehow they'd managed to break physics. Like, how was it possible that you could sit and play a PlayStation 1 game and have this like orchestral music playing all the way while you're playing a 3D game where the world loaded in advance? So how the hell did they do that? Well, do you know what they did? They got access to the source code of the CD driver and they modified, because the thing about a PlayStation era device was it's really a piece of electronics. It's not like a computer. And so you have complete access to all of the software in the device. You can literally transmit bytes of memory from memory through a bus to the processor under your control. You have total internal control of the device. And so they rewrote the driver that drove the CD. So instead of its normal behavior, which is to be told somewhere on the CD to go, and the head to move there over a period of time, like a second, and then start reading and then jump somewhere else, they changed it so that it was like on a slide, basically. It would circle, and they wrote a tool to lay out the bytes on a CD in a particular format that interleaved 3D geometry and texture information and the music. So that instead of requesting files from a CD like you would on a PC, you got this constant stream of music and sound and texture and 3D data as it was spinning around. And they had another tool where you could an AI effectively would play through the game with a 3D streamed world, and it would calculate what files needed to be in memory in order to draw the world at each point in the game. So you can imagine like a racing game or any kind of game like this, somewhat linear game. And then what it would do is it would lay out the bytes so that the head reading the CD never had to move very much in order to get the information. And most of the time, it didn't have to move at all. It was basically just like following a single continuous track, cycling around the CD, if a normal player was playing the game at a normal speed. And because of that, they could absolutely maximize the amount of information that was coming from the disk into memory and onto the device. Now, you think about how many levels of sophistication, how much perseverance is required to do that. And think about how many times you would have, I would have, anybody would have given up before they did that. So one of the things that they did was active perseverance. Active perseverance was to say, what is the best that I could possibly do? What is the theoretically best solution that could ever be produced? And how do I design that? How do I work back from that? And I am going to study everything necessary to make that possible. And then I'm going to produce a result that is completely different in its nature from what everybody else is doing. And that will give me this moat, this quality moat that other people won't be able to touch. And that will give us a strategic commercial product advantage, which they absolutely did. And that to me is a wonderful example of active perseverance. And so next week, we will talk a bit about how it might be possible to get an AI and a human to engage more in active perseverance and what the long-term wins are from having that as a value system. Okay, I hope you found that useful, and thank you for your time, and I will chat to you again next week if you're available. All right, thank you.